Welcome everyone back after this long break with the World Cup. I'm very glad to have you here. This week we have Professor Jordi Galí, who is the director of the Center for Research in International Economics, CREI, and he's also affiliated with the Barcelona Graduate School of Economics and University of Pompeu Fabra. And Professor Galí is going to talk about his paper with Luca Gambetti on the effects of monetary policy on stock market bubbles. Some evidence that, as I understand, is a follow-up of a theoretical paper that he wrote that is forthcoming in the American Economic Review. So you have his webpage, and also you have access to the paper. So I'm not going to do this introduction any longer. I just want to thank Professor Galí for accepting giving this talk. This talk was a recommendation by our colleague Carolina Pagliacci from the Banco Central de Venezuela, who pointed us to this paper. So I thank Carolina for this hint, and without further introduction, please let me welcome you.
Okay, well, thank you so much, Alberto, for the invitation. It's the first time that I do one of these webinars, so let's see how it works. So my apologies in advance for any clumsiness on my part, and again, feel free to ask questions, and hopefully I will realize that you're asking a question, and I will remember what I'm supposed to do in that case. Okay, very good. So this is joint work with Luca Gambetti, and the overall topic of the paper has to do with how monetary policy influences asset prices. But the ultimate goal of this is to draw on this evidence to think about how monetary policy should respond to asset price fluctuations. Okay. So again, this is the main what you see here on the screen. The first line is the main question that motivates this research program. Now, the answer to that question has evolved over time. Before the crisis, there was a widespread consensus among, I would say, both academic economists and policymakers that central banks should focus on inflation on the output gap, on stabilizing those variables. Okay, that is on what we would call macroeconomic stabilization, and they should essentially forget about asset price developments unless they could signal a threat to the stabilization of inflation and the output gap. Okay. Now, this consensus has been called into question, or has been challenged, at least by the crisis. And there are one thing that we know for sure is that macro stability is not a guarantee of financial stability, and the financial crisis that started in 2007, 2008 is a clear proof of that. But the main argument that has been made for more of a systematic response of monetary policy to asset price fluctuations is that an important component of asset price booms, like the one that we experienced in the 2000s, may be bubble-driven. Okay, and the problem with such bubble-driven booms is that they may end up in a crash, and that crash in turn may generate a financial crisis, which may have important macro implications. In particular, it will generally lead to a recession that is more protracted and harder to fight than a regular recession. So this has led to some thinking, and in some cases even to some calls, for what we could call, or what I'm going to call here, a leaning against the wind policy, which would consist in raising interest rates in response to developing asset price bubbles, okay? With the objective, again, to dampen that asset price bubble, or to eliminate it, or to prevent it from growing too big, okay? Very good. Now, there's an important assumption that underlies this conventional view. The conventional view is that, you know, an increase in the interest rate will lead to a reduction in the size of the bubble. Okay. Now, when this presumption sounds quite natural, because we tend to think in terms of what I call the fundamental price logic. We think of an asset price as being the discounted sum of the dividends that asset generates. So if the interest rate goes up, the rate at which we discount these future dividends goes up, and hence the price of the asset goes up. Okay. Now the problem with this is that this applies to the fundamental component of the price of an asset. That's clear, but it doesn't necessarily apply to the bubble component of the price of an asset. The reason is that if you think of a bubble, by definition, and we'll see that more formally later on, a bubble has no payoffs that can be discounted. Okay, and as a result of that, the return on the bubble corresponds exactly to the growth in the size of the bubble. Now, as an equilibrium requirement is that the expected return on an asset, in particular the expected return on the bubble, has to correspond, if not exactly, at least it has to move with the interest rate. Okay, so it follows that the expected growth of the bubble, or the bubble component of an asset, should correspond to the interest rate. So if the interest rate goes up, then at least in expectation, or if you want on average, the growth rate of the bubble should increase. Okay, now. So this is what this is a point that I made in an earlier paper that just came out in the AER, and of course an implication of this is that if a central bank systematically responds to the size of a bubble in the economy through one of these leaning against the wind policies, it runs the risks of amplifying the fluctuations in the size of the bubble, and potentially amplifying the instability in the economy. Again, because higher interest rates may, if they are unsuccessful at killing the bubble, they may lead to higher growth in the bubble. Okay. So that was the basic point in my earlier paper. What we do in the present paper is to try to come up with some evidence on the effects of monetary policy on asset price bubbles. Okay, that is to confirm or to refute the theoretical point that I just made, or to see whether the conventional view, namely the one that associates higher interest rates to reductions in the size of a bubble, holds instead. Okay, so it's essentially an empirical paper. Now, before I turn to the empirical evidence and to the methodology that we adopt to answer that question, let me walk you through the simple analytics of interest rates and bubbles. Okay, so this will be a simple summary of the basic point that I made in my earlier paper, and it will provide the reference framework for the empirical evidence that I will show you later. Okay. Now consider. Let's see if this works. Okay. Yeah. So consider an asset. Okay. So this will be partial equilibrium. Just a simple example. Consider an asset which generates a sequence of stochastic dividends, dt, okay, and take the real interest rate to be given by RT, the gross real interest rate, and to evolve exogenously, okay, for the time being. Now, for simplicity, let's assume that investors are risk neutral. Okay, in that case, we can define the fundamental price of that asset by the expression that you see on the screen. Okay, so essentially the expected discounted sum of future dividends. Again, under the simple expression arises when investors are risk neutral. Now we can derive. I won't do it here, but one can derive a log linear version of this, because later on in the empirical evidence, and when we look at our empirical work, we used the logs of different variables, and the log linear version of this fundamental asset price is given by the expression that you see here, where now the lowercase letters refer to the logs, the natural logs of the original variables. Okay, so we have the log of the fundamental price of the asset is some discounted sum of expected future dividends, but we are subtracting also this interest rate, the evolution of the real interest rate. Okay, so this is the log. The interest rate is little r is the log of the gross real interest rate. So you can think of it as just the usual real interest rate. Okay, the net real interest rate. Very good. Okay, so that was the fundamental component of an asset price. Now, we define the bubble, and essentially this equation that you see here, you can interpret, or we should interpret as the definition of the bubble. Okay, we define the bubble component, okay, QB of the price of an asset as the difference between the observed price QT, okay, and the fundamental price. Okay, so this is a definition. Okay, and from that definition, if we take a log linear version of this identity, okay, and we think, okay, what we're interested in is in how each of these components responds to a monetary policy shock. Okay, to a change in, let me call it a monetary policy shock that leads to changes in interest rates. Okay, so let me denote epsilon TM that you see here, okay, as the as the generic notation for an exogenous monetary policy shock. So this term here will be the impulse response function to the observed asset price Q, to the monetary policy shock. Okay, so it's how it gives us how the percent change, if you want, in the observed stock price at horizon K after an exogenous monetary policy shock occurs in period T. Okay, so given this identity here, this impulse response will be just a weighted average of two impulse responses. Okay, one is the response of the fundamental component, and the other is the impulse response of the bubble component. Okay, eventually, I mean, our goal in this paper is to learn about the response of the bubble component to the monetary policy shock. Okay. Now the weights, this is a weighted average, and the weights are given, and this is important, by these gammas, gamma which are time varying. Now, what are these gamma? Gamma and 1 minus gamma. Gamma is just the share of the bubble in the observed price. Okay, so if there was no bubble, this gamma would be equal to 0, and the response of the observed price would correspond to the response of the fundamental. But if there is a bubble, or if a part of the price corresponds to a bubble, then this gamma will be positive. Obviously, it has to be between 0 and 1. Okay, and hence the observed price will respond to also will be affected by the response of the bubble to the monetary policy shock. Okay. Now, both the straightforward finance theory and the evidence that I will show you later, and also some of the evidence in the existing literature, imply that the fundamental component will go down, okay, in response to a monetary policy shock that we interpret as a tightening of monetary policy. So in particular, a monetary policy shock that leads to an increase in real interest rates. Why is that? Well, again, we go back to the expression that we had for the fundamental component. Okay, typically, if we look at the impulse response of each of the terms in this expression to the monetary policy shock, okay, we would expect dividends, if anything, to go down in response to a tightening of monetary policy, and the real interest rate, to go up in response to a tightening of monetary policy. So unambiguously, okay, we would expect the fundamental component to go down in response to that tightening of monetary policy. Okay, so this derivative, if you want, would be negative. Okay, again, this is not something that is at stake. Okay. Okay, so now there are some.
There are some questions in the chat.
I see some questions here. Okay, so let me. Is it possible that the evolution of the share of the bubble is also a function of monetary policy? Definitely. Okay, so. If so, how does the missing terms in this equation would bias the result? No, because notice that I'm letting gamma t, okay, to change over time, and this is important, and this will, to a large extent, justify the main approach that we use in this paper. Okay, so in principle, monetary policy, again, there are two things. This is a log linearization. Okay. And so you should interpret this as a local approximation, but we are allowing this gamma to change. Okay. If it is a function of a monetary policy, I think you will be able to affect the size of the bubble with the interest rate. Yes, then that's what this paper is about. We'll try to learn how, if the interest rate influences the size of the bubble. Okay, and yes, the question on the risk premium that Ken is raising is something that I will delay to the end of the talk, because the way I have defined the fundamental component, okay, again, and this is an important point, maybe I didn't emphasize it sufficiently, is the fundamental component conditional on investors being risk neutral. Okay, then we'll have to discuss what happens if we allow for time variation. In the fundamental component. Now, there's a question on what is the origin of financial bubbles? How these bubbles emerge, I leave completely unexplained. The only thing I can say, and this is a point that was illustrated in the previous paper that I referred to, is that there is a class of models in which even rational bubbles, there is Bush bubbles that may exist in an equilibrium with rational expectations may exist. Okay, and how they emerge, we don't know, because there's multiplicity of equilibria associated with that. More in a second on this. that is, how they emerge or what the precise size is left unexplained. But again, more in a second about this. What we want to emphasize here is how they respond to changes in interest rates. Okay. Now, if gamma equals 1, you rule out bubbles by assumption. Are you ruling out some? No. If gamma equals 1, if gamma equals 0, presumably, you mean if gamma equals 0, then there are no bubbles, and the observed prices correspond to fundamental prices, and fundamental prices are well defined. I mean, okay. Then whether fundamental prices can be driven by sunspots or not is beyond the goal of this paper. And I'm sure I can think of models in which sunspots may affect real variables, and there may be fluctuations in those real variables that are driven by sunspots, and those will affect the fundamental price. But still, in that case, the observed price will satisfy this equation. Okay, independently of what are the driving forces behind the drivers of fluctuations in dividends and real interest rate. Okay. So the conventional view. Let me try to move ahead a bit, because many of these questions will be addressed in what follows. The conventional view implies, again, we all agree. I hope that the fundamental will go down in response to a tightening of monetary policy. Now, what I call the conventional view assumes or presumes that the bubble component will also go down in response to a tightening of monetary policy. Okay, so that's this is what I would call the conventional view. So if both the bubble component and the fundamental component go down in response to a tightening of monetary policy, the observed price should unambiguously go down in response to that tightening of policy. Okay. Very good. That's the conventional view. Now let me put that aside, and now let's look at what happens in a model with rational expectations. Again, under the assumptions that I'm still maintaining, which are risk neutrality and an exogenous real interest rate. Okay. Now, in a rational expectations equilibrium, the following relationship must be satisfied. So this is essentially, if we were to move this Q here to the right-hand side, dividing, okay, what the equation would say is that the expected return on the asset should be equal to the real interest rate, and that's the condition that we know that has to be satisfied in a rational expectations equilibrium, okay, under risk neutrality. Okay. Now it turns out, and I'm not going to prove it here, but it's relatively straightforward to prove that given the way we have defined the fundamental component, which is, it's completely standard and conventional, okay, the fundamental component satisfies also this difference equation, okay, and that can be checked, again, by going back and checking that the expression for the fundamental component satisfies this difference equation. Okay, now subtract this equation from the equation on top, okay, and use the definition of the bubble, okay, and you get immediately a result that is maybe familiar to many of you, because that's well known from the earlier bubble literature, that the bubble component has to, again, in this rational expectations equilibrium, or if it is a rational bubble, has to satisfy this difference equation that you see here. Okay. Again, move the QTB to the right-hand side, dividing, and what you see is that the expected growth rate of the bubble has to correspond to the interest rate. Okay, that's the result that I mentioned earlier. Okay. Now, equivalently, we can rewrite this again. Here's where a whiteboard would be useful. We can rewrite it like this: the realized first difference of the log of the bubble component, that is the growth rate, approximately the growth rate of the bubble component. Now remember that Q is the log of the bubble component. It has to be equal to the real interest rate, okay, plus this term, where this term CT is just the unexpected or movement in the bubble component. Okay, and the only constraint here is that this CT, this prediction error, the unexpected movement, is unforecastable. Okay, it's what we would call a martingale difference process. Okay, but again, if you take, conditional expectations given the information set at period t minus 1, okay, you get the basic relationship that the expected growth rate of the bubble must be equal to the real interest rate. Okay, this is essentially what this equation tells us. Now, here I have rewritten this equation, but for time, I have moved time backward one period. Okay, very good. Here we see the basic point that I made earlier. Okay, in this environment, a tightening of monetary policy that leads to an increase in real interest rates will lead to an increase in the growth, and at least the anticipated growth of the bubble. Yeah, I don't think. Yeah, so here again, the idea was you just.
But it is really tricky.
Yeah. So you just take expectations here, then this term goes away, and you get the basic relationship in logs that was implicit here. Okay, that the expected growth rate of the bubble equals the real interest rate. That's all I meant to say. I'm sure that all of you captured that. Okay, very good. So now here, so the basic result is that a tightening of monetary policy raises the anticipated growth of the bubble. Okay, but how about the level of the bubble? Okay, and this is important. Now again, here I have just rewritten the relationship that we had just derived. Okay, now the only constraint on this term, on this C, and this unforecastable change in the level of the bubble, is that it's unforecastable. Okay, so in principle, it could also be related to the unforecastable movement in the real interest rate. Okay, so without loss of generality, okay, we could write down this CT. Okay, this innovation. I'm going to call this CT from now on the innovation in the bubble. There is the unexpected change in the bubble. Okay, we can write it down as the sum of two components. The first component is related to the innovation in the real interest rate, okay, and the second component is just a component that is unrelated to changes in real interest rates. Okay, very good. Okay, so now we see that monetary policy could in principle affect the size of the bubble through a different channel, namely through a hypothetical effect on this CT. Okay. However, it's important to note that theoretically the size and the sign, even the sign of this CT coefficient here, that it's a coefficient that relates the innovation in the bubble, CT, with the innovation in the interest rate, is completely indeterminate. Okay, so this could be large, could be small, could be zero, and it could even be it could be negative, it could be positive. Okay. It's not determined by the theory. The constraint that the theory imposes is that that this CT is unforecastable, and this will always be the case independently of the value of C. Okay. But again, this is something to keep it in mind for what follows. Okay. So now we are ready to derive an expression for the response of the bubble component to the tightening of monetary policy. Okay, so it will be given by, on impact, that is when k equals 0, it will be given by this term. Okay, it will be given by this CT that we see here. Okay, times the change in the real interest rate, contemporaneously in response to the tightening of monetary policy. Okay, so that will determine the immediate or the immediate impact of the tightening of monetary policy on the bubble. Okay, and then over time, again, that is for k greater than k equal to 1 or greater than 1, then the response of the bubble will be influenced by this, okay, by the evolution of the real interest rate, and of course in a positive way for the reasons that we mentioned earlier. Okay. So now let's go back to the expression that we had earlier for the response of the observed price, okay, the observed price of the asset, okay, which again, it was a weighted average of the response of the fundamental and the response of the bubble component, okay, with these gammas given by the relative size of the bubble relative to the price, okay. Now, so what is the prediction regarding the response of observed asset prices? Okay. Now, suppose that the bubble is small. Okay, that is gamma is close to 0. It doesn't have to be 0, but close to 0, and or CT is very negative. Okay, that is the bubble responds very negatively to innovations in the in real interest rates. Okay, so in that case, unambiguously, okay, we will have that the observed price will decline, okay, in response to a tightening of monetary policy. Okay, because we know that now the fundamental declines, and now we're stating conditions under which either the bubble will decline, okay, will be very negative, or the bubble is so small, okay, because gamma is so small that it will have a negligible impact on the observed price. Okay, so essentially, what this condition, if this CT is very negative, what will happen is that this component, which obviously will be negative, will more than offset this second component here that is positive. Okay, that's the point. If C is very negative, it's large and negative. Okay. So in that case, we would get a response that is according to the conventional view. Now, suppose on the other hand that the bubble component is large, relatively large, so gamma is large, closer, it doesn't have to be close to 1, but it's far from 0. And suppose that this psi, which again that the economic theory leaves completely undetermined, is not too negative. Okay, that is, it's positive or close to 0. It could be negative, but close to 0. Okay, in that case, this term here will dominate this first term here, and as a result of that, the bubble will respond positively to a tightening of monetary policy. Now, if the bubble is large enough, if gamma is large enough, this may more than offset the negative response of the fundamental component, and at least for large k, that is for a sufficiently large or long horizon, we may observe an increase in asset prices in response to a tightening of monetary policy. Okay. What is the intuition for this? Again, the intuition is that investors will require, if interest rates go up, investors will require a higher return on their investment, and when it comes to the bubble component of the investment, higher return can only be attained by an increase in the size of the bubble. Okay. Again, this is not a new result. I'm not claiming at all that this is a new result. This goes back to the earlier work on bubbles by Jean Tirole and others. And the question is, what are the implications for monetary policy of that result? Okay, and that's what this focuses on. Okay, so here let me show you some simulated responses. Again, essentially to show you that anything goes here. Okay, so for under alternative calibrations. Okay, so take the black line. The black line shows us the case in which gamma equals 0. There's no bubble. Okay, so but this is under some assumption again. Let me see. Oh, okay, I had skipped. Sorry, I had skipped one slide. Okay, so let me give you a simple example, a simple parametric example, just to illustrate the wealth of possibilities. Okay, so suppose that the dividend doesn't respond to the tightening of monetary policy, and suppose that in response to this exogenous tightening of monetary policy, the real interest rate adjusts over time. It goes up initially and then gradually goes down to its original level according to this simple geometric process, as if it followed an AR1 process, okay, where rho r is a measure of the persistence of the real interest rate. Okay, now I won't go back to the formulas that I showed you earlier, but one can use those formulas to derive a simple analytical expression for the impulse response of the fundamental component, okay, to this tightening of monetary policy under these assumptions, and this is the response, and it's always negative, okay, and it will be more negative the more persistent is the tightening of monetary policy on the effect of the tightening of monetary policy on real interest rates, okay, and here is an expression for the response of the bubble to that tightening of monetary policy. Again, this can be positive or negative. Depending on C. If C was 0, okay, this would always be positive, okay, because the only monetary policy would influence the bubble only through the effect of real interest rates on the anticipated growth of the bubble, okay, but if C is different from 0, of course, this can change, okay. So now let me go back to this picture. So this shows possible, for this simple example, possible responses of the observed asset price, okay, excuse me, to the tightening of monetary policy. Okay, so the black line shows what would be the conventional response, which corresponds to the case in which gamma equals 0, that is, in which there's no bubble. Okay, so what you see here is just the response of the fundamental component. So there's a tightening of monetary policy, the fundamental component goes down, and it gradually goes back, since the shock is stationary, it gradually goes back to its original level. Okay. Now suppose that we have a bubble, and let's assume that gamma is 0.5, so the bubble accounts for 50% of the observed price. Okay. Now different things can happen. Now take the blue line. So in the blue line, we have that C, that coefficient equals 0. Okay, so in that case, in this simple example, in which I forgot, I must have calibrated rho to some value. I forgot now, maybe must be 0.5. Okay, so in that case, originally we have a decline in the response of a decline in the observed price, okay, because the fundamental component dominates. But over time, the bubble component dominates, and since the bubble component is increasing, we see that the observed price eventually goes up. Okay. Now, if C is negative, instead, that's the red line, we can have we get a different. Oh, thanks, Alberto. Rho is 0.8. You must have checked the paper. We get again an initial decline, but now the decline is larger than the decline of the fundamental. Okay, and in fact the stock price never goes back to its original level, because there's a persistent or permanent negative effect on the bubble component. Okay. And then another extreme case is a case in which C is actually positive. That is, the bubble innovation responds positively to the innovation in the interest rate. Okay, and then we could get a response like the one represented by the green line. Okay, now the stock price increases in the short run, and it keeps increasing over time. Okay, so we get a permanent positive effect of a tightening of monetary policy on the observed stock price. Okay. Now, again, according to a theory, all these are possibilities. Okay. Now, what is clear is that the response represented by the blue line or the response represented by the green line are clearly at odds with the conventional view. Okay, the conventional view would suggest that, well, of course, if there's no bubble, then the response would be like the one we see here. But if there is a bubble, the conventional view would imply that the response of the observed price would look more like the red line. Okay, which, you know, since the bubble component declines in response to the increase in interest rates, then we would have, you know, a very negative impact of the tightening of monetary policy on the asset price. Okay. Now, what happens in reality, again, it's an empirical issue because, you know, again, theory tells us that many different things can happen. So that motivates this paper. So now let me turn to the empirical work. Okay, so the goal of the paper is to just to estimate the response of observed stock prices to an exogenous monetary policy shock, and to see whether, you know, which of these four patterns, you know, describes better the estimated response of stock prices. Okay. So what is our approach? We use VAR. Okay. That's our starting point. It's a relatively standard VAR that we use to identify exogenous monetary policy shocks, following very much the Cristiano-Eichenbaum and Evans strategy. Okay, so here you have this would be the reduced form VAR. So these are the variables that we include in vector XT. We have the growth rate of GDP, we have the growth rate of dividends. Again, lowercase letters denote the logs of the original variables. Here, this would be price inflation. If I recall correctly, we use GDP deflator inflation. This is the change in the log of a commodity price index, again, following Cristiano-Eichenbaum and Evans. This is the federal funds rate, which we take to be the instrument of monetary policy. And this is the growth rate of the S&P 500. Okay, so the change in the log of the real S&P 500 index. Okay, so this is all US data that we use, and these are just the, you know, I won't get into the details of structural VARs, but basically. Here we assume that the innovations in this vector of variables have this variance-covariance matrix sigma, and which is constant over time at this point. And the other important assumption is that this vector of innovations is linearly related to some structural shocks, some underlying structural shocks, one of which is the exogenous monetary policy shock. Okay, so these are just normalization as standard normalizations. We assume that these structural shocks have a unit variance and that they are orthogonal among each other and serially uncorrelated. And so here are the key identifying assumptions. And again, we follow as much as possible Cristiano-Eichenbaum and Evans. We take the federal funds rate to be the instrument of monetary policy, and we assume, okay, that GDP, dividends, real dividends, price inflation, and commodity prices are predetermined with respect to IT. That is, they do not respond contemporaneously to an innovation in the interest rate, and in particular to an exogenous monetary policy shock. Okay. And if we think of, again, notice that IT is in the fifth position here, so we interpret the fifth element of epsilon t to be the exogenous monetary policy shock. Okay, so the assumption that it will implicitly make is that S is block lower triangular. Okay, this matrix S is block lower triangular. Okay, now this implies also, and I'll come back to this later on, that we are assuming that the Federal Reserve has not historically responded contemporaneously to changes in the real S&P 500. Okay, and I'll get back to this when we discuss the results. Okay, that is, to be clear, we are allowing the S&P 500 to respond contemporaneously to monetary policy shocks. I think it would be completely inappropriate not to allow for that contemporaneous response, given that the stock prices, are very sensitive to news about monetary policy, as we all know. But what we're restricting is the endogenous response of monetary policy to changes in the S&P 500. We are allowing, in principle, the central bank, the Federal Reserve here, to respond to asset prices, but only with a lag. Okay? And again, more on this later. Now, what's the problem with this approach? Okay, so this is how, I guess, the first thing that would come to our mind if we want to estimate, the effects of monetary policy, the dynamic effects of monetary policy shocks on stock prices. Okay, but if there is a bubble component in stock prices, this VAR standard, time invariant VAR representation would be clearly misspecified. Okay, why? Because we have just seen before that, the response of observed stock prices to a tightening of monetary policy will generally depend on gamma. Okay, that is on the relative size of the bubble. Why? Because the response of the bubble component is likely to be different, or even very different, from the response of the fundamental component. Now, if that gamma changes over time, and there is no reason why it shouldn't change over time, then we should allow, the response of the observed stock price, and maybe of other variables too, to change over to the response to a tightening of monetary policy to change over time. Okay, and that requires using a time-varying vector autoregression, which is the one that we follow here. Okay, now here Julio Carrillo asks if we try to different identification sign restrictions. We didn't try sign restrictions. I would have to think about it, but I don't think it would be. The sign restrictions would be okay as long as certainly what we don't want to restrict is the response of the stock price, and that may be an alternative way to go, as long as you don't restrict the response of the stock price, because that's actually, we want to learn whether that response is positive, negative. Okay, because as we just saw, the theory allows for both, but we haven't tried that in this paper. Okay, yeah. Okay, that's what you're saying. Yeah. Very good. So here is the general specification of the VAR with time varying coefficients. Essentially, what we're letting these A's vary over time, the A's in the VAR to vary over time, the variance covariance matrix of the innovations to vary over time, and the ST, the matrix that links the structural shocks to the innovations, also to vary over time. Okay, so does the ordering matter? Yes, it may matter. We just pick the ordering that we think it's possible. Okay, so again, the identification is the same. Okay, but the only thing is that we're letting all these coefficients change over time, and now the natural question is how. Obviously, the changes over time cannot be completely unrestricted. We need to impose some structure, and here we follow the approach that my co-author has followed in many papers, and essentially it builds on an approach that it was originally proposed by Primi-Cherry. And again, I won't get into the technical details, but let me just give you the basic point here is that we're letting all these coefficients evolve over time, but in a smooth way. Okay, we're not allowing for huge jumps. Okay, so essentially this theta parameter that collects all these coefficients follows a random walk. Okay, and all the coefficients of the variance matrix are also allowed to follow a random walk. That's what this is. That's what this is saying. And of course, now we're going to estimate this using a Bayesian approach, and we have to put some priors on the variances of these innovations. These are innovations in the in the process followed by the coefficients, and we're going to restrict them that they evolve smoothly over time. In principle, our approach does not allow for asymmetric, responding to one of the questions by Raul Ibarra, our approach doesn't allow for asymmetric responses, as you will see. Okay, so that's a good point, and it would be interesting to maybe to think of approaches that would allow for that sort of nonlinearity, because maybe bubbles more than other variables are likely to respond asymmetrically to positive and negative exogenous monetary policy shocks, but this approach does not allow for that. Again, the only advantage of this approach relative to the standard one, the linear one, is that we are allowing for this time variation in the responses to monetary policy shocks, because the theory tells us that if there is a bubble, such variation may actually be time variation may actually be important. Okay, so let me turn to the evidence. So first, I'm going to show you some impulse responses using the constant coefficients VAR. Okay, so here you have 4 variables, and then I'll show you 4 more variables. So these are pretty standard. These are the responses of 4 variables that people typically include in these structural VARs when they want to identify and estimate the monetary policy response. So you have the federal funds rate, okay, which goes up persistently in response to the identified monetary policy shock. What you see are 2 standard error confidence bands. The real interest rate follows the nominal rate. We know that because prices are relatively sticky. So the real interest rate follows the nominal rate. As a result of this tightening of monetary policy, GDP declines quite persistently and significantly. And the GDP deflator eventually goes down. In the short run, it hardly changes, and there's a bit of a price puzzle here, but eventually the GDP deflator goes down. Okay, so these results are similar to the ones that many other people have uncovered. People typically don't include dividends in these VARs. We do, and I'll tell you why we do. This is the response of dividends. Again, perhaps not surprisingly, dividends like GDP also go down in response to a tightening of monetary policy. And this is the response of stock prices, the observed, again, log of the real S&P 500. Okay, so stock prices go down in the short run, okay, but then they gradually go up and they end up higher than originally. Notice also that the confidence bands are large, okay? And this is something that we cannot do much about. Now, let me show you so our approach allows us to recover the fundamental component of stock prices. Why? Because we have the response of dividends, we have the response of the real interest rate, and earlier I showed you an expression for the fundamental component of stock prices in logs, which was a function of the response of dividends and the response of real interest rates. Okay, so here's the response, the implied response to the fundamental component, and you see that, not surprisingly, it goes down quite a lot, minus 2 percentage points in response to this tightening of monetary policy. Okay, and what you see here is the fundamental, the response of the fundamental component against, or in the same picture as the response of the observed price. Okay, so we see that the observed price doesn't go down as much as the fundamental component, and its gap tends to, it doesn't return to zero, but it actually turns to increase, so the gap tends to increase. Okay, again, you may want to think of the gap, roughly speaking, as the bubble component. Okay, so this would be more consistent, more in line with a response, maybe like the blue one that I showed you here. Okay, but again, it's subject to the criticism that if there is indeed a bubble, then given that the bubble component responds to differently from the fundamental component, then it is not appropriate to use a VAR with constant coefficients. Okay, so that's why that motivates the use of a VAR with time varying coefficients, and now I'm going to show you the evidence based on that VAR. So here's a question here. Did we apply any transformation to the original data? No. I mean, we just took the log and we deflated. Well, first we deflated the S&P 500 with the GDP deflator, and then we took the log. So no other transformation. Okay. Its stock prices are very volatile, but that doesn't mean that they should be very volatile, or they should show a very erratic behavior in response to monetary policy shock. Okay, that much of that volatility, I would suspect, would be hidden or would be captured by the innovation in stock prices. Okay, but we're not looking at that. Okay, so let me show you this. So I'll have to invest a few seconds in because we'll see many of these, and they all have the same structure. Okay, so it's important to be able to read these 3D pictures. Okay, so what you have here is a family of impulse responses, one for each quarter. Okay, and real time is here, or chronological time is here. So for each quarter, okay, you have an impulse response. Okay, and the impulse response is along this axis. Okay, so time, the shock hits the economy, and then whatever variable is plotted, the federal funds rate here, evolves over time. Okay, so what we see is the response over a 20-quarter horizon. Okay. Okay. I think, guys, the volatility is captured by interest rates. The volatility of stock prices may not necessarily be captured by interest rates, but again. So here is the federal funds rate, and again, this is it's not particularly interesting, other than by learning how to read these pictures. So why it's not interesting? Because it doesn't change much over time. Okay, the response of the federal funds rate to an exogenous monetary policy shock has been relatively constant over time, as you see here. Okay, let's look at the response of the real interest rate. Again, in response to a tightening of monetary policy, the real interest rate has increased, and then it gradually goes down to its original level. Okay, and that has been relatively constant over time. Okay. Here's the response of GDP. Again, we would expect GDP to contract in response to tightening of monetary policy, and we see indeed a contraction. Okay, quite substantial. Okay, so GDP goes down as much as 1% roughly. Okay, in response to that tightening of monetary policy, and here we see more of a change over time in the response of GDP. And I want you to remember this because we may later on we may see a possible interpretation. It will be completely speculative of why this has changed over time. So notice that the response seems to become smaller over time. Okay, this is actually something that Wavin and Giannoni noticed in a earlier paper. Okay, but again, this is not the focus of our paper. Here we see the response of the GDP deflator. The GDP deflator goes down over time, very gradually. Okay, but again, not major changes over time. Here's the response of dividends. It's a bit peculiar. It's not, it shows this funny pattern that we didn't anticipate. But again, for most of the time, the response is negative and quite persistent. Okay. We have this slight increase in dividends in the short run in the most recent period. Okay. Now we looked at the robustness of our results when we eliminated the most recent years, okay, which are the ones that correspond to the crisis in which dividends show that pattern, and again the results don't change. Also, as I'll mention later, we redid all our results using earnings instead of dividends. Earnings are much better behaved time series. Those of you who've used dividends and earnings are surely aware of that. And again, the results are robust to that. Is the size of the monetary policy shock changing over time? That's a good question. No, it's one standard deviation all the time. Okay. But of course, it's one standard deviation in the epsilon corresponding to the monetary policy shock. Now, if you want to know whether that corresponds to very different, degree of tightening of monetary policy, you have to look at the impulse responses of the real interest rate. Obviously, they change over time, but they change very little over time. Okay, so this is the experiment that we're looking at. Okay, how the economy responds. That's how I want to interpret the experiment that we're looking at. How the economy responds to this exogenous tightening of the real interest rate. Okay. Okay, the time varying results suggest that something changed after 2000. Well, the crisis, that's a good point. That's why we got rid. Well, actually, if you look at things more carefully, you see quite a substantial change in the more recent years, the years of the crisis. So that's why we got rid of those. Well, we did some robustness and eliminated those. And one possible interpretation of those changes had to do with the zero lower bound. Okay, it's we're forcing an exogenous monetary policy shock on a variable that doesn't really change, so that may distort a bit the results. But again, the results, quite the quantitative results that I show you, are robust to getting rid of the most recent part of the sample. Now here's the most, I guess, the central finding. Okay, so this shows the response of stock prices to the tightening of monetary policy. Okay, so look at the earlier period. Okay, the 60s, the 70s. Okay, the 60s and the 70s. Okay. In response to a tightening of monetary policy, stock prices go down quite a lot, actually. And then they gradually return to their original level. Sometimes not completely after 20 quarters, but roughly they are back to their original level. Okay, so that would be fully consistent with the conventional view about the response of stock prices to monetary policy shocks. Now, look at what happens starting in the 80s, mid-80s, and certainly 90s and 2000s. Okay. Again, the intervention is very similar. The path of interest rates is very similar. Okay, and now we also see a decline in the stock prices in the short run. But instead, over time, you know, they increase, and they increase very fast, and they end up higher than they were originally. Okay, and this seems to survive for the whole period, again, after 1980s. Okay, so obviously one interpretation of this is that during this period, after the 1980s, there was a significant bubble component in stock prices, and that bubble component responded differently from fundamentals, and that may account for this. Okay, so let's see more evidence to confirm or not this conjecture. Okay, what you see here is the response of the fundamental component, and again, the response of the fundamental component doesn't change much over time. It's largely dominated by the response of the real interest rate, okay, rather than the response of dividends. And what we see is that the fundamental component goes down quite persistently, but gradually it returns to its original level. Okay. Now, we had the response of the observed stock prices. We have the response of the fundamentals, so we can compute the response of the price minus the fundamental. Okay, and that gives us an approximation to how the bubble responds. Okay, so again, there's an important change over time. Okay, and we see that in the early part of the sample, this price minus fundamental goes down, and then it gradually goes back to zero. So this would be consistent with what I call the conventional view. Okay, but after the 80s and certainly the 90s and the 2000s, things change, and this bubble minus this price minus fundamental, if you want this approximation to the bubble component, actually goes up or hardly changes initially, or goes up a bit, and then it keeps growing over time. Okay, so again, this is consistent with that pattern, one of the many possible patterns that I showed you earlier, and that was associated with a bubble that doesn't change much in response to the monetary policy on impact, but it gradually increases in response to the higher interest rates. Okay. Very good. So what else? We have a question here. QE. Is it sensible to conclude there is no bubble now? That's a good question. On the basis of this, I would say no. Okay. Let's see, because actually, to be precise, our approach does not allow us to uncover in order to answer your question, which is actually what originally we were after too, we will need to somehow recover gamma, and we cannot identify gamma. We cannot identify the level of gamma, so we really cannot say whether there's a bubble or not. What we can say is whether stock prices respond or not. If there was no bubble at all, I mean, the response of the observed price minus the fundamental would be at zero, and we don't observe that. Okay, so that suggests that there is some deviation from the price from the fundamental, and hence there must be a bubble. But we cannot quantify the size of that bubble as much as we would like to be able to quantify it. Let me skip this. This is just a different way of presenting the same results. Let me show you. Actually, I didn't show you confidence bands. It's very hard to present confidence bands in this interval. This is some results gives us a sense of the the precision or imprecision of our estimates. Okay, so what you have here is for different quarters, okay, in real time, okay, the response at different of the gap between observed prices and the fundamental prices at different horizons. Okay, so we have impact, that's the red line, then you have after 1 quarter, after 1 year, after 3 years. Okay. So this is the probability of a positive response. Okay. So ideally, we would want that probability to be 95%, but you can see that we reach those significant levels. We don't reach those, or only in the most recent period. Okay, so the probability, but still we get substantially positive probabilities of a positive response of that approximation to the bubble component at different horizons. Okay. Very good. And these are pictures that I like quite a bit because I think they are clearer than the previous ones. They tell us a bit how these responses have evolved over time, and they related to specific episodes. Okay. So what you see here is an average of the impulse responses over a 3-year period. And here you have the 3-year period. This is, I took a relatively arbitrary 3-year period in the 60s. Okay. And you see the response of the observed price, that's the red line, and the response of the fundamental component, on average, over that 3-year period. Okay, and you see that the observed price goes down in response to the tightening of monetary policy, and the and it goes down even more than the fundamental. Okay, so that would be consistent. If there was a bubble, it would be consistent with the bubble, being particularly sensitive to monetary policy in a way consistent with the conventional view. Okay. Same thing for the 70s, very little change. Okay. And now here is the 80s, and here we have chosen the 3-year period right before the crash of October 1987. Okay. Why this period? Well, because we have many people believe that 3-year period is a period in which a bubble was building up in stock prices. Okay, and here you can see a substantial difference in the pattern of the responses. So in particular, the observed price ends up higher, and there is this gap between the two, which represent the bubble, that is growing over time. Okay. Similar picture for the period before the dot-com crash. Okay, there is a period in which we may suspect, or we may believe there was a substantial bubble. Okay, so you see here again a clear pattern in which the observed price eventually goes up, and the gap between the two seems to be increasing. Again, consistent with the theory. Now, robustness analysis. Again, this is the result I mentioned earlier. What happens when we get rid of the crisis period? We end our sample, I think, in 2007 Q3, I believe. Okay, so what you see here is the response of Q minus QF. Okay, so that would be the fundamental component. Again, things are very similar to the picture before, but that's not too surprising, because that's one advantage of models with time varying coefficients, that they are less likely. The results for periods in which the model is misspecified, or in which there are data problems or whatever, are less likely to be contaminated by those periods, okay? By the periods in which there are data problems or behavior is very different. Again, there are problems. We noticed earlier that dividends behave in a funny way, and actually dividend series are actually not pleasant to work with, because they are highly seasonal, and seasonal adjustments are not very good. So we repeated our estimates using earnings instead of dividends. Okay, the whole thing, obviously the theory in principle applies to dividends, not earnings, but we did it with earnings. And we get a very similar. Again, what you see here is the response of Q minus QF, okay, the gap between the observed stock prices and the fundamental component, and you see the similar pattern, okay, an increase over time in response to a tightening of monetary policy. Okay, so let me, and now, since we don't have much time, 10 minutes, let me address possible criticisms that, either we thought about or people raised in response to earlier presentations of this work. Okay, one that is, a natural one is the possibility that there is a time-varying equity premium. Okay, how does that affect our results? Well, it affects our results in one specific way. Our measure of the response of the fundamental component is based on a definition of the fundamental component that assumes risk neutrality, or equivalently, a constant equity premium. Okay, that we could have a constant equity premium, and that wouldn't change. That wouldn't change the result. But what happens if the equity premium is time varying? Okay, then obviously our measure of the response of the fundamental component would not be correct, because it is ignoring one component of a fundamental component, which is the time-varying equity premium. Okay, but the natural question is the following. Okay, what kind of response? What kind of response of the equity premium to the tightening of monetary policy would be required to explain our results without the need to rely on bubbles? And the answer to that question is the equity premium should go down substantially in response to a tightening of monetary policy. Okay. Now there is independent evidence of that by Bernanke and Kotler and other authors that we refer to in the paper, which suggests exactly the opposite. And also, common sense may suggest the opposite. Also, the literature and somewhat, indirectly related literature that looks at measures of the equity premium, like spreads and so on, and how they behave in corporate spreads, corporate bond spreads, how they respond to the tightening of monetary policy. They suggest that those measures of variation in risk, as those increase. Okay, so we think that variation, a time-varying equity premium, there is an equity premium that responds to an exogenous monetary policy shock, cannot explain our results. Another question that has often been raised is, well, here we've seen the response of short-term rates, and short-term rates indeed increase in response to a tightening of monetary policy, but what matters for the pricing of stock prices or for stocks is long-term rates, and we know that long-term rates have not necessarily responded as the theory, the expectations hypothesis say implies they should have responded. Okay, so in principle, long-term rates could have gone down in response to the tightening of monetary policy. Okay, but we checked that, and the answer is no. Okay, so what you see here is the estimated response of the long-term interest rate to a monetary policy shock. And again, long-term interest rates may not respond like the expectations hypothesis implies, but they certainly went up, and quite persistently, in response, throughout the sample period, in response to a tightening of monetary policy. And the final point is simultaneity. Okay, remember, one of the assumptions is that we make is that monetary policy does not respond contemporaneously to changes in stock prices. Okay, they may respond, but with a lag, but not contemporaneously. Now, there is some work by Sachs and Rigobon that called into question that, not didn't call into question that assumption, but it looked at that particular issue, suggesting that there may have been, and the findings suggest that there may have been a contemporaneous response. Now, in our paper, we refer to some recent work by Furlaneto that has re-examined, has revisited the Sachs-Rigobon results, but allowing for variation over time. And they show that the Sachs-Rigobon result hinges critically on what happens in 1987, okay, in which the Federal Reserve reduced interest rates dramatically in response to the crash of stock prices. If you eliminate that period, then that result vanishes, and instead the evidence is suggestive of no response or no significant response of monetary policy to stock prices. Okay. Ken, you're asking about the difference with your work. If I recall, obviously the approach, the methodological approach is different. But also, if I recall correctly, I would have to go back to your paper, you did not really look at the dynamic responses over time of stock prices. I'm very sympathetic with Kuttner's surprises, as that's not the issue. But I think you focused very much on the the responses in the very short run. I may be wrong, and I would have to go back to that. Okay. Gamma cannot be recovered, as I mentioned. In a structural setting, you may be able. If you estimate a full-fledged model, you may be able to recover the gamma. I haven't thought about that. That may be a way to go. Certainly, with our simple approach, we can. And sign restrictions. With sign restrictions, we could. That's a good point. We could allow. We could allow the central bank to respond, to increase interest rates in response to increases in stock prices. So that's that. Again, if one is willing to take that approach to identification, I guess this would provide a natural setting in which there is a natural sign restriction, so to speak. Okay. Which also allows for a no response. Okay. Let me just conclude, and I will try to answer any questions at the end. Again, these are just. I think I have some pictures at the end, which if I have some time, I will try to show you. Just a summary of the results. Again, the conventional view that those who call for leaning against the wind policies, monetary policies in response to asset price bubbles, is that an increase in interest rates reduces the size of the bubble. As I mentioned earlier, the theoretical foundations for that are at best fragile. Okay, certainly there are no strong theoretical presumption that this is that an increase in interest rates should lower the bubble. If anything, it's the opposite. Okay. Now, admittedly, those theoretical results rely on two assumptions, or maintain two assumptions, namely that bubbles are rational, so it's in a rational expectation framework. And of course, if bubbles are not rational, anything can happen. And secondly, there are no financial frictions whatsoever. In the framework this partial equilibrium framework that I showed you, and in my AER paper, there are no financial intermediation. Now, in fact, in equilibrium, there are not even credit flows. Okay, so some people claim that monetary policy may affect bubbles through the potential impact on credit, and credit may have an impact on bubbles. I'm not questioning that, but again, this is beyond the scope of the theoretical framework I showed you. Okay, empirical support. Well, as you've seen, the evidence does not favor the conventional view, and if anything, is consistent with some of the theoretical implications that I showed you, and hence it's consistent with leaning against the wind policies being destabilizing, at least potential. And in any event, I want to emphasize that these have to be these results. I don't want to push some extreme policies that of the sort that the central bank should lower interest rates in response to a bubble, which is the optimal policy implied by economic theory, as I showed if the bubble is sufficiently large, as I show in my other paper. The only thing is that the message that I really want to convey is that we need to understand much better how monetary policy affects asset prices, and in particular bubble component of asset prices, before we implement any policies that involve a systematic response of interest rates to any estimates or any suspected bubbles. Okay, so let me leave it here and try to address some of the questions. My microphone is enabled. Okay. Okay, yes, I don't know where I had left this. Could gamma be recovered? Oh, okay. Let's see. If increasing the premiums and bonds are caused by expectations and chance of shot. Have to think about this. If increasing caused by expectations, equity. That contractionary monetary policy are the drivers of the crisis. And the drivers of the crisis are intertwined. I see. Oh, okay. So that's a deeper question than I thought. By BCV. This suggests that there's some that the VAR is not capturing well the exogenous monetary policy shock. I take it to be like that we're not identifying well the monetary policy shock during the crisis, and so I would have to think about that. But in any event, the results seem to be robust to eliminating the crisis. Okay, so yeah, about Ken. Well, we should let me go back to your paper and I don't remember seeing impulse responses, as you say. So that's what would be nice to compare. And I would be very happy to say that I should present this at the BAS. I would be very happy to present it there. So you should tell Claudio, see if he wants to invite me. A few policy-oriented questions. Would it be sensible to say that the tightening of monetary policy to prick bubbles would be a bad idea? That's an interesting thing. Again, that's something that an issue that I had to deal with in my theoretical paper, in the AER paper. If monetary policy, theoretical, if monetary policy is so effective at raising real interest rates sufficiently that bubbles cannot exist, then of course this result goes away. Okay, the bubble would explode. Okay, I didn't in my model, in the model that I showed you, I didn't model the collapse of the bubble. Okay, that's why? Because at least if it's a rational bubble, that's one equilibrium among many in general. Okay, the bubble can collapse at any point in time. Okay, now of course, what central banks could potentially do is to raise real interest rates sufficiently that the bubble is inconsistent with the rational expectations equilibrium. Okay, so that's a possibility. Okay, however, if the central bank doesn't succeed at doing that, then the risk is that the bubble may be increasing along the way. Oh, okay. Now, would it be sensible to say that tightening of monetary bubbles would be a bad idea? And it might be a bad idea. Well, whether it's a bad idea or not depends on whether you think that the boom, the tightening of monetary policy to print bubbles would be a bad idea. I'm not sure I understand. So why? Here I didn't really get into whether bubbles were desirable or not. A tightening of monetary policy may, again, as I said, it may prick the bubble. It would be maybe a good thing if it leads to a collapse of the bubble early enough. Okay, but you know, if it happens too late, that may come with all the consequences that we know that bubble collapses imply. Okay. Now, would an increase in stock prices be a way out of deflation or improve deleveraging? Would an increase in stock prices be a way out? Well, if you know, that goes beyond what we did here. Certainly, if an increase in stock prices stimulates aggregate demand and it stimulates consumption and investment, that would be it would help fight deflation, and it would be most welcome. Or improve deleveraging. Would it improve deleveraging and increase in stock prices? Again, to the extent that you know, if you believe, as I believe, that the main problem certainly in the euro area is insufficient aggregate demand, and if stock prices and if you know, if we manage to increase aggregate demand, that would take care of the potential deflation problem. It would speed up the deleveraging process as well. Then if an increase in stock prices raises aggregate demand, then it should be welcome. But that's independent of whether it's driven by a bubble or not. Does your conclusion support contention that U.S. financial was caused by loose monetary policy? Okay, that's more closely linked to my paper, and that's you know, that's an important question. Well, if you take our results seriously, then you should conclude that the Taylor criticism is not right. Okay, because the bubble or the growth of the housing price bubble, okay, would not be a consequence of too low interest rates. Okay. Again, we don't know. We didn't see fundamentals, housing price fundamentals during that period, and thus we don't know what the response of the bubble may have been. Okay, but certainly the more direct interpretation of our evidence here is that, you know, too low interest rates during the 2000s may have been a bad idea for other reasons, okay, but not necessarily in the sense that they have necessarily fueled the bubble. Again, ours is a framework in which financial considerations are not present. Okay, if too low interest rates, as my colleague Jose Luis Pedro, among others, suggest that have led to banks and investors taking excessive risks, you know, that in turn may have fueled the bubble. Okay, but that's through a different channel than one that you would find in a standard model. Okay. Well, I think okay, agree with the last point. That's good. I don't know if there are any more questions. Alberto, are we done?
Yes, perhaps if no one writes down a question or raise their hand, let me just put here the link where they can look at your papers. I noticed that in your web page you have a December version, and the one that we posted on the web page is a March, or let me see the exact date. Yeah, it is in March 2014. I guess they are the same ones.
Oh, it's very similar. It's very similar. It has been accepted the AEJ now, and it's a very, there are just formatting changes or very
So it is
minor changes.
It is coming there, and everyone can also get the other paper, the one we were talking about on monetary policy and rational asset price bubbles, that came out in the American Economic Review in that same webpage. If
yeah, that you can find it on my webpage. Yeah. I think it was in the February issue, I believe, of the February 2014.
So, on behalf of everyone who participated today, let me thank you for sharing with us your paper, and let me take the opportunity to remind everyone that you can look at the full schedule of the seminars in the link that I just posted. We'll be meeting every Tuesday at noon U.S. Eastern Standard Time through this same platform, and during July we will also have Itamar Dreschler from NYU, who will be talking next week about the model of monetary policy and risk premia. And then we'll have Anton Korinek from Johns Hopkins University, who will talk about his paper on global cooperation or currency wars. Then we'll have Ken Kotner from Williams College, who will talk about if can non-interest rate policies stabilize housing market, evidence from a panel of 57 economists. Timothy Furst from Notre Dame University will follow with his paper on optimal contracts, rate risk, and the financial accelerator. And then we'll have Monica PHSC from Stanford University talking about bank risk exposure. And I think Matthias Bastian, who is around here, will follow also in August. So thank you, everyone. Thank you again, Professor Galí, and the paper is there.
Thank you very much, everyone, for the comments.
Yeah, and I'll send you the recording that we made for you to have all the comments and questions that you received. Thank you very much.
Okay, great. Thank you so much. Bye-bye.